My name is Ashish Mahabal, and we'll be looking further at R today. So let's start with assignments. We saw last time that you can use the less than arrow and dash to do the assignment as is shown in the second line here, and that is what is preferred. So here we show that you are assigning 3.14 to z. As we said before, doing z equal to 3.14 is also possible, but you should at best avoid that. And there are a couple of good reasons for that. I think one of the reasons that people feel that using two keystrokes is not a good idea, but most editors that go with R allow you to use the less than dash, including the spaces on the side with a single keystroke. So you should get into that soon. In Emacs as well as in RStudio, there are keystrokes available for that. But the main reason is that equal to gets used for keywords. Look at the next line. We saw an example of rnorm before too. Here we are taking an rnorm 100 numbers in that vector, and there we say mean equal to 5. So here the keyword is mean, and we are saying that we want a mean of 5 for that vector. Here you cannot use the less than dash. Equal to is reserved specifically for that. And then people tend to get confused if you say a equal to rnorm 100 and so on. Plus, there are two other things. If you want to use global variables, and we'll be seeing an example in the next slide, there you have to use less than dash. So the next line shows how you are assigning 7 to the vector y. More than global, it's actually an assignment to the enclosing scope. So whatever scope encloses that particular statement, that particular variable gets set in that particular environment. And of course, if you are using equal to, you still cannot use equal to to do the global assignment, because equal to is of course for checking something. So z equal to 3 is where you are trying to check whether z equal to 3. So that can get quite confusing. So you should always try to use less than dash for the assignment. And then for global, of course, you have to use less than dash. And then for keywords equal to, and for checking, you have to use the two equal tos. So get into that habit as soon as you can and stay that way. So this is how one would use enclosing scope variable sets. So if at the prompt you simply say bar, where you are trying to find out the value of bar, and if bar has not been set before, then it's going to return an error that I don't know what bar is. But then what you can do is that you can set bar in different ways. Here we see also how to define a simple function. The function is defined with the keyword function, and then it is followed by parenthesis, and within the parenthesis you can give it the arguments that you want it to give. And the return value is the object foo in this case, so that is the name of the function that we'll be using. And all that we are doing within the function in this particular case is setting bar to 1. But what we are saying is that set the bar equal to 1 in the enclosing variable, in the enclosing scope. So if you now come out of the function definition, and if you run foo, then it's going to do that setting for you. And then if you ask what bar is, though bar was not defined outside the function, you will get the appropriate value for bar equal to 1. So again, less than dash will set the variable in a higher enclosing scope, and that is what you should do when you need to do that. Well, avoiding something like that is always good, but that's the facility that's available. Then again, we can assign entire vectors using the combine. So we saw this example before, how you can assign several different values using combine to variable x. So what is actually happening here is a specific function called assign is being called, and the function assign takes two arguments. The first argument is the variable name that you are giving, x in this case, and the second argument is a combined set based on whatever inputs you have given. So that is what is internally being called. There's another quirk with assignment that you can do in R, and that is another thing that you should avoid as best as possible. You can do an assignment on the right hand side also. So you can say combine these 5 values for me, and use a dash and greater than, and then a variable name there. That will work equally well as the first argument, but again, you shouldn't use that unless you have to for some specific reason. And then you can easily work on entire vectors as if they were variables. So if you have assigned 5 values by combine to x, you can do 1 by x and get reciprocals of all those numbers. Similarly, you can combine vectors with each other. Here in the next line, we see that we took the vector x, a 0, and the vector x again, combined them. So we had 5 values in x, and this combination is going to have 11 values. So those 11 values can be assigned to y. Similarly, you can use the function repeat. And now I'm trying to assign to v a combination of things here. I'm saying that repeat x and add to that y and add to that 1. So 1, of course, is an atom, and y is something that has 11 values, whereas x has 5 values. So what it's going to do is it's going to try to repeat x as many times as necessary so that its length equals the longest of the 3 arguments on the right-hand side. In this case, y is 11, so it will repeat x 2.2 times, and then it will repeat 1 11 times. And so you now have 3 sets of 11 values, and those would be added as the first one with the first one and so on, and you'll get a vector v, which will again have 11 values. And of course, you can combine many of these things very easily. So in the next one, we are finding how variance is. We say that take the mean of x, our 5 values, then you subtract the mean from each of the values of x, square that and divide it by the length of x minus 1. So you can combine those easily, write those as functions, but all those things are available as various functions also. And remember, help is available whenever you want that. So simply saying help sum is going to tell you what it is that sum is actually doing. Another important construct is an R frame. And an R frame is easy to read into. So you can have a simple space-separated file. So here I'm talking about a file that contains simply 3 lines. The first line has num space name1 space value 2, and the next 2 actually have some values, 1 space 1.1 space 3 and 2 space 4.4 space 4, right? What you see in the table on the right-hand bottom. So if you have an ASCII file of that nature, then you can read it in trivially into R. You can simply say read.table, and the file name in this case that I'm using is called foo. So I read in the file foo, and I say header equal to true, meaning that the first line there is going to define the names of the columns for me. And once that is done, X now contains the entire file, and you can do various things with that. Objects is a way to look at the objects that your R, current invocation of R knows about. And if you give it without any arguments, just the empty parenthesis, then it will tell you about all objects that R knows about in your current invocation of R. But X is where we have read our table into. So you can also say that tell me what are the objects available in X. And then what it will show you are the names of the columns that you have. And if you type simply X, then the entire frame will be printed out for you. Name1 is one of the variables there. If you simply say name1 at the R prompt, and each of the commands here that you see are something that you can give on the R prompt. So if you say simply name1, it's not going to give you anything back because it doesn't know about name1. The name1 happens to be inside the object X. And to access objects within another object, you have to use the dollar symbol. So X $name1 is what will give you the name1 column there. That is where namespaces come in. That's another thing that we had talked about in the best programming practices. So you should try not to modify things by combining namespaces. But if you have to do that, or if you're going to use only one namespace, you can do that by saying attach X. When you do attach X, then the objects within X become available to you on the command line or in the enclosing environment that you're using. And after that, if you say name1, then you will see the column called name1. Redirection is easy to use in R. Just like in Unix, you would use the less than to redirect from a file or greater than to redirect to a file. Similarly, in R, you can use source and sync. So source myfile.r will read from that file various commands that you may have given there, and sync out file will write to a file whatever output that you are creating. Just like the Unix command T, you can also use sync with a keyword called split equal to true. So when you do that, you'll see the output on the command line as well as save it to a file. And you can also capture the output into a variable instead of a file by using capture.output. So here we are saying that if we want to capture the output of what example of buy is going to give you, then that will get stored in that particular variable. We talked a little bit about R data earlier and R history. R history saves the commands that you have been given so that you can easily go back to that. LS lists for you various objects, and you can use these recursively or in tandem with other objects. So the last line here shows how you can say that assign the output of LS, the objects that you have, to a vector called list, and then you can remove everything that is in list. Of course, you shouldn't try to do that in a script, because then whatever you have done up to that point in the script is going to get erased. So in R, everything returns something. In that sense, everything is a function. Then the other things to remember is that spaces do not matter, but capitalization does. So if you are using capitals in some cases, you have to continue using those. Parameters often have odd names. They can be named, that's a very good thing, but because of the organic nature of how different packages are, some of them can have fairly odd names, so you should get used to those. You can use NA for missing data, and is.na with empty parentheses is a very useful construct, so you should try to inculcate that early on. So it does the corresponding test to check whether a particular point is available or not. We saw X reading the table. There we saw how you can read it with the header information, but you can also specify the column names in the command line itself. So all these functions, you should look up the help. So help read.table will give you the GORI details of a large number of keywords that are available with it. If you don't give the names through the header or through the command line call to read.table, you can always give names later on simply by saying names of X equal to, and give whatever names you want by combining the combine function. Then a large number of standard functions are available. The plus, minus, power, etc. are there. Various trigonometric ones are available. And then there are functions like sort.list and order also. The pmax and pmin are interesting in that they return vectors. So if you had a data frame which had numbers, and you said max of that data frame, it won't worry about the different columns and rows. It will combine all of them as if it was a vector and give you a single number. On the other hand, if you use pmax, then it's going to give you a column-wise maximum. And there are various other such functions available also. Square root, as you can see here, we are getting a square root of a complex number, so it's clearly overloaded because you can use the same square root for just ordinary numbers and get it equally well. Sequences are another important construct. Simply doing 1:30 gives you the numbers 1 through 30. Again, R starts with 1, not with 0, so you should remember that. In this case, colon is also a function. So when you say 1:30, that function is being invoked. And colon binds in a strong way. So if you do something like assign 10 to n, and then say that I want sequence 1 going from 1 to n minus 1 using the colon function, then the colon is going to bind. So you are going to get 1:n first, and then 1 will be subtracted from each of them. So if you want to do something slightly different, you may want to enclose n minus 1 into a bracket. Similarly, 2 star 1:15 is going to give you 2, 4, and all multiples of 2 up to 30. So sequences can also, of course, take named parameters. You can use from and to and by and length. So here you could have something like sequence of length 51 starting from -5 with jumps of 0.2. That's a trivial thing to do. You can also use repeat within that. So sequence of 5 here, we are assigning to that a repetition of x times equal to 5. So it's going to take it's going to give you x and then another copy of x and another copy of x. Instead of that, if you wanted repeats of individual elements first, then you can do each equal to 5 rather than times equal to 5. So again, doing just help repeat is going to give you all the GORI details of what is available. Another important construct is the logical vectors. So you can assign to n x, but only where x is greater than 13. So what this is going to do is it's going to find out which all values are greater than 13, assign them to true, assign true to them, assign false to the others, and then write the vector n. So the vector n is going to have the same length as the vector x. You can similarly do intersection by using and, union using or, and negation using bang. Remember also that false becomes 0 and true becomes 1 when you coerce them, when you say that, okay, you want numbers rather than the logical values. And then similarly, missing values, you can use them wherever you want to, and that's another very important aspect of R. Indexing is also a very trivial thing to use. Just square brackets and 1:10 is going to give you the first 10 values of it. Similarly, if you want to leave out something, that's easy also. Just minus and then in round brackets 1:5 will do that. Replacing missing values, that's something that is needed very frequently when you deal with data sets. So you use the function is.any of x that finds out for you where that particular thing is true, and then only for those values you assign 0. So immediately all the missing values will be replaced by 0. And then the next line shows how absolute y can be defined in a different way also. Now z, assigning to z something like 6, 7, 8, that vector, and then trying to replace only one value out of that, what it's going to do is that it will make the 6, 7, 8 into 6, 7, 5. But when that is done, a copy of z is first made. And in the copy, you replace the third one with 5. And when this is being done, actually the square bracket less than dash is being used as a function. And so again, many functions are used in very interesting ways internally. Similarly, you can go to arrays and matrices. Remember, if you simply said C of 3, 500, you are going to get a vector with those 3 values. But instead of that, if you assign that to dim of z, then you are going to get a 3D array with those sizes. So you'll get an array of size 3 by 5 by 100. Similarly, you can combine various sections out of 3D arrays and combine them in a trivial fashion. If you want the entire array, you can use commas. So square brackets and then separated by empty commas is going to give you the entire array. Next couple of lines indicate something quite interesting. Here, what we are doing is that we take the numbers 1 to 20, we make that into an array, and the keyword dim tells us that it should be a 4 by 5 array rather than say a 2 by 10 array, and we assign that to x. Then we make another 3 by 2 array. In this case, we call it I, and there we are denoting the values that we want within the array by 1:3, 3:1, and those 6 values now, we say that arrange them in the 3 by 2 dimensions. And then if you say something like x of I and assign zeros to those, then what's going to happen is that the 3 by 2 array that is in I is like 3 pairs, and those 3 pairs represent 3 positions. And those 3 positions are looked up in the array called x, and it is those 3 positions that are set to 0. So in this particular case, you can work that out as an exercise. The positions 9, 6, 3 are what correspond to what we have set in I, and those values within x will get set to 0. So you can do fairly complex things in that fashion. And again, for data massaging and data munging, these functionalities are very useful. Now, looking at a variant, what you can do is that you can combine different structures into a single structure also. So here we have something called name, Fred, wife, Mary, number of children, 3, and child ages, a vector. So we have a vector here, a number here, and some strings. Those can all be combined into a list and assigned to something called LST. You should remember that these are always numbered. So if you want the value of in the 4th parameter of this particular list, you can say LST with 2 square brackets of 4, and then it's going to return you the vector that is there for child.ages. And if you want the age of a particular child, then you will suffix that list with 2 square brackets of 4 with 2. So that will give you the second value of 7. If you were to leave out that second pair of square brackets, that is the enclosing second pair of square brackets from the 4, it's going to return null to you. And then if you were to ask only for LST of 3, it's going to give you a number back. So you have to remember that if you want to get to one of the specific elements, you can use the square brackets combined with individual elements within that particular one. Then there are matrix operations. You can simply do A star B element by element matrix product, or you can do matrix multiplication. Again, look at the slightly quirky ways this is used, %* for matrix multiplication. And there are a large number of matrix operations that you can do. I mentioned earlier that reading a file through read.table that we did, you can look at help of that and you can see lots of various keywords that you can use with that. There are some built-in ones to specifically read.csv, read.csv2, and so on, so you should also look at that. Then we'll be looking at more details about various other commands and objects within that. So attach we have already seen. Here I'm simply giving an example of plotting that. You can read a data set and then you can attach those variables within that and you can simply plot two different variables in there. Pairs is one such example. We'll be seeing more details about plotting later. So I just wanted to give you a hint of how to use that with a single command. So let's not go into details of that right now. And next time we'll be talking about built-in data sets, packages, debugging, and get to the basic plotting that I hinted at here.